Okay, one more bit of functionality I want to show, which you're probably already aware of, but I want to show it anyway, is how to remove elements from the STL linked list. And then we'll make our own. Okay, so let me just show you this real quick. So to remove an element, so let's say for example, we wanted to remove all elements that were odd. Okay. Now I've made a slight change here. I've actually made my int wrapper inherit from this this abstract class printable, which has a single pure virtual method print. So what I'm saying is anything that inherits from printable needs to implement this method called print, and it should print out something about the object. Okay. So I just changed the code slightly. This will come in handy in a moment when we go to make our own thing. But just to remind yourself how pure virtual classes work, how abstract classes work. Nothing much changes here, except now I can use a more general type as what's being contained in this list. And actually I can just call the abstract method, and polymorphism will actually handle the specific implementation that's needed. Okay, cool. But let's say that I happen to know that it's an int, and I want to filter out certain elements from this list. So what I have to do is something slightly different from this for loop. I'm actually going to use a while loop instead. It'll be slightly more convenient. But I'll start at the beginning of the list. I'm going to want to walk through the whole thing, and I'll remove all the elements that are not evenly divisible by 2. Okay. So I'll say, as long as I haven't reached the end, I want to keep looking and seeing what's there. I do happen to know that these are int wrappers. So I will say my element is equal to, well, let me actually cast the dereferenced iterator. Okay, so I'm going to follow that arrow right to the element. So dereference the iterator. Generally, there's supposed to be references to printable, but I know that it's actually a reference to something more specific here. So I can take this out. And then I can actually access this public element that it's wrapping. And so I'll say if that thing, the thing it contains, happens to not be evenly divisible by 2, then I'll actually remove it. Okay, so remove. So how do I do that? Well, I call this method called erase. So I say array, or I say my iterator is equal to array.erase iterator. So what that does is the following. So if I go back to this picture, let's say that my iterator is here. Okay, so here's my iterator. What it's going to do is when I say iterator.remove, it will actually circumvent the, let me see if I can draw a nice arrow here. It will circumvent the entire next thing, and it will just jump me straight there. So when I say remove, it will change the next pointer, the arrow that comes out of this, to completely jump over this and go to the thing after that. Okay, so then so it does that. It actually changes the list in that way, or it's said to mutate to the list. That's the word, mutate. And then the iterator jumps here. Okay, and so effectively, this arrow no longer exists. If we're following these arrows, we will never actually visit this ever again. Okay, so for the future, the list has actually changed because we've changed what these point to. In the meantime, our iterator has moved forward as well to where this new arrow points. Okay, but otherwise, if we don't want to filter this out, we should just keep moving. Just keep following the arrows as normal. Now we should be careful, since these were dynamically allocated. Before we actually, before we move on, okay, so fine, we can remove the element from the list, but we need to make sure that we also delete the dynamically allocated thing that we no longer will be able to reach, right? Because if we didn't delete this, well, there's no way to get to it anymore. It's going to be a memory leak. So don't forget to delete it. Okay. So let me just see if that works. And it does. Okay, cool. So when I run this, I see only the even numbers that were perfect squares up to the range that I had allocated before. All right, good. So that is just something to be aware of, and that will help on homework 3. So we will now continue on and make our own version of this.